Yeah. Okay, guys, are there any questions on those first two? 1 and 4. Well, fine. Just use the formula. The thing in number 4 was that they gave you the diameter, so you had to halve that. Because in this formula, obviously we're working with radius, not with diameter. Okay, for numbers 2A and B of the previous one. Okay, for 2A and B there of exercise 17.1, sorry, I said the previous one, I meant the next one. It's a little bit early. The first one was finding the area or the total surface area of a triangular prism. So that's what I did there. You had two identical triangles. Remember, for a triangular prism, that's always the case. You have a triangle at the bottom, and then you have a triangle at the top, and they are always the same. Then, guys, as I started writing down the three rectangle areas, I noticed actually after I was writing them down separately, I noticed that they were actually all the same. All right, so instead of doing your three rectangle brackets separately, you could have written it as 3 times 1 bracket. Okay, so it's fine if you did that. Let me just add that in there. But you can also write them separately, it doesn't matter. But instead of doing these 3 separate brackets, you could have just said 3 times 980 times 560. And the reason for those 3 rectangles being the same is because it was actually an equilateral triangle. All right, so all 3 sides of the triangles were the same. So all 3 rectangles that came off of those sides were also identical. Any questions on 2A? Then for 2B, that was a rectangular prism. Now, guys, we actually wrote down a formula for the rectangular prism, which you can use. The formula was, I can't remember the exact order now of all of these sides, but it was 2 times length times breadth plus 2 times length times height plus 2 times breadth times height. All right, so you can apply that formula and then just obviously fill in the length, breadth, and height where they should go. Guys, the order of these 3 terms doesn't matter. Okay, so you can put them in any order as long as you're adding them together. Or what you could just do is you could think, okay, what shape do I have at the front and the back? It's 2 that are identical, so I'm going to find the area of each of them and multiply it by 2. Then at the top and the bottom, those ones are also identical. So 2 times top and bottom area. And then the 2 on the sides are also identical. Right, so it's up to you whether you just want to think of the faces of the shape or if you actually want to use the formula. Any questions, guys? Okay, we're moving on to volume today. So that is the new heading, please. Volume of 3-dimensional shapes. Or let's say volume of solids, that's better. Volume of solids. Okay, guys, now volume is basically, they say in the notes here, the amount of space that a three-dimensional object or solid will take up. So total surface area is the area of all the faces all around, okay? Just the area. We're not actually interested in what is going on inside that shape, inside that solid. Volume is how much of a certain quantity that solid can actually hold. Okay, say, for example, how much air there is inside that solid. So here we have, I'm not going to redraw all of these pictures. We'll just go through it quickly, but all of this is in the notes. Okay, all of these diagrams and so on. We will write some stuff down, but we're just going to go through it here. if you remember from the above section, the previous section, which was just total surface area, three-dimensional shapes or solids have a height. And that is what makes it three-dimensional, right? Because we have the base, which is a flat two-dimensional shape. As soon as you add a height to it, it becomes three-dimensional. All right, so there we can see that diagram. Just like we had a squared unit for area, we now have a cubed unit for volume. Guys, some of you used millimeters cubed and so on for the area questions in the test. All right, millimeters or centimeters or meters or whatever cubed, that is only applicable when we get to volume. Okay, so let's just make a little note here on the side. It's going to be whatever the unit is cubed. All right, so units cubed. So if it's millimeters, you're going to write your answer as millimeters cubed. If it's centimeters, you're going to write your answer with centimeters cubed. Okay, they say there in real life, we think about volume by asking how much of something like water, sand, air, etc. could we fit inside these different shapes, and would those amounts increase or decrease when we change the shape's measurement? We're going to talk about that later on, all right? But do we understand the concept of volume? It's what goes inside or what can fit inside the shape, all right? Total surface area is outside, volume is on the inside. Now they have all the different prisms here that we need to work with. That is a cube, that's a rectangular prism, that's a triangular prism, and that is a cylinder. All right, those are the four that we've worked with so far. We've done the total surface area of all four of these. Now we need to do the volume. Now guys, volume is actually very easy, much easier than total surface area, because volume is always the area of the base, whatever shape the base is, multiplied by the height of that shape. The area of the base of the shape multiplied by the height. So we're going to just summarize the four shapes that we've done. The first one is the cube. Now guys, if we're thinking of a cube, what shape do we have all the way around? It's a square. So does that make sense that the base will also be a square, right? If all of the faces are squares. So for a cube, the base is a square. And what would the area of that square be then? So area is then, you can say length times breadth, but because it's the same, we often say just side times side, all right, which is side squared. Then the height of that cube, if we're just looking at the picture quickly, right, that is a cube, for example. This area here, that's side times side. Are we fine with that? Then what would this length be? The height of the cube is actually also the same as the other sides, right? So do we agree that the height of the cube is also going to be S? Right, so the height is also equal to S. So to get the volume, the formula for volume, we're going to say the area of the base, which is side squared, multiplied by the height, which is another side. And guys, what is side squared times another side? Side cubed, hey? So the volume is side squared times side, but we can actually just work with side cubed. All right, that is the formula for the volume of a cube. Side cubed. Side times side times side. Okay, next one. Rectangular prism. Now guys, for a rectangular prism, the base is going to be a rectangle, right? That's why it's called a rectangular prism, because the base is a rectangle. And we all know that the area of a rectangle is, sorry, I'm doing nonsense here. I didn't want to do that bracket there, sorry. The area of a rectangle is length times breadth. Okay, so that would be the area of the base. The height of a rectangular prism is just going to be called h, right? We're just going to call that height h, which is what we've been doing so far, right? Whenever we've done the surface area of a rectangular prism, we've just said that that is h, the height. So the volume here, guys, is going to be the area of the base, which is length times breadth, multiplied by the height. So that's also an easy one to remember. The volume of a rectangular prism is length times breadth times height. Okay, you just take the 3 dimensions and you multiply them together. Yeah. So for cube, it's just going to be side cubed because the area of the base is side squared, and then we multiply it by the height, which is the same length. That's why we call it S again. But guys, if this confuses you, you can use length times breadth times height for this one as well. They'll just all be the same number. Okay, we'll look at it now when we do an example. Okay, number 3. A triangular prism. Now, the thing about a triangular prism is that sometimes they're going to draw the triangular prism so that it's not actually lying on its base. All right, if we look at this picture here, what shape is it standing on? What shape is at the bottom of this whole prism? A rectangle. But guys, the base is actually a triangle. All right, so in this case, it's a bit weird because the base isn't actually the side that it's standing on. All right, for triangular prism, the correct base, even if it's drawn in a different way, is always the triangle. Okay, so that's something we need to remember. So for triangular prism, that's why it's called a triangular prism, because the base is a triangle. Okay, even if it's drawn so that it's not standing on that triangle. So the base is equal to a triangle. And we all know that the area of a triangle is half base times perpendicular height of the triangle, right? But now for volume, we're going to have to multiply that by the height of the actual prism, which is different from the height of the triangle. Okay, so we're going to be working with 2 different heights, which is why for this one, we're going to call it a capital H. Okay, because there are 2 different ones. We can't work with a small h and a small h because it's actually 2 different things. So guys, if we're looking at this, this triangular prism, the height of the triangle, the perpendicular height, let me just draw a little line here, is going to be that. All right, that line is going to be the perpendicular height of the triangle. The height of the prism is this. Right, does that make sense? You're going to see now when we do examples. So there are 2 different heights that we're talking about here. We need to include the height of the actual triangle, that is the one that's the base, and then the height of the prism, this is going to be the height. Okay, you guys can copy all of this down now underneath when we're done summarizing this. So the volume is going to be area of the base, so half base times perpendicular height multiplied by the height of the prism. Okay, so that one is a bit confusing, all right? It is a bit easier if you just think, okay, I'm finding the area of the triangle on its own, and then I multiply it by the actual height of the prism. Okay, but we will practice that. Okay, the last one is a cylinder. And for a cylinder, the base is always a circle. Again, guys, even if it's not drawn that way, all right? Sometimes they're going to show you a cylinder that's lying like on the tube part, that's lying on its side. We need to remember that the proper base of a cylinder is a circle. And now this was a question in the test. The area of a circle is pi radius squared. The height of the cylinder now, because we only have one height that we're working with here, we can just call it small h. You can call it a capital H if you want, doesn't really matter. So the volume of a cylinder is going to be pi r squared times h. Right, any questions at this point, guys? I'm going to put the pictures of the 4 shapes on the board now, and I want you to draw them underneath your summary here. I'm going to fill in all of the dimensions that we've used now in the formulas. Okay, so you can copy that down, yeah? Area of the circle and then the height of the actual tube, yes. You have to work out the other area. No, so we only do that when we're doing surface area, when you would do the 2 circles separately. For volume, it's always only the one base multiplied by the height. Yes. Sure. Okay, guys, there are the pictures. All right, so just draw them. And in this order, because this is the order that we wrote the formulas down. So put an S and an S and an S. Don't worry if it's not perfect. Okay, it doesn't matter. This one is length and breadth and height. That is H, that is B, and that is capital H. And then for your cylinder, you just need to do a dot and then show that that is the radius. And then this is the height. Okay, I'll give you a few minutes to copy that down. Oh, and guys, for your L, you don't have to write the L like that. I just do it so that it doesn't look like a 1. Okay, so I just do a cursive L just so that no one gets confused, but it's fine if you want to do a normal L. Then you must just remember that it's an L and it's not actually a 1. Okay, that's the only thing. If you're done copying that down, you can maybe start on a new page and just write examples. That's what we're doing next. Okay, guys, can I take that off? Maybe just take a picture if you're not done there, and then you can just finish it up. Okay, now, are you guys tired of drawing now? Or can you draw some more? All right, let me just zoom in a bit. That's a bit small. Those are the first two that we're going to do. You don't have to draw them. You can write down rectangular prism, length is 65, breadth is 26, height is 57. Let's do that. Is that fine with you guys? Okay, I'll put the picture back up again. If you've started drawing it already, that's also fine. But what we're going to do, sure, now I'm writing on my sub slip. Okay, that's fine. We're going to say it's a rectangular prism. The length is 65 millimeters. Do we agree with that? All right, the length is that side over there. The breadth is 26. And the height of the whole prism is 57 millimeters. So I'm just writing it on my page quickly. I know some people are drawing it. Yeah, no, that's fine. You can copy it down. It's no problem. All right, you guys can work out that volume so long if you're ready. Okay, we've written down the formula for volume. It's length times breadth times height. But guys, I want you to write it down properly, please. Write down the formula first. So literally the formula that we wrote down in the summary. You're going to write down V equals L times B times H. Equals, then you're going to show me length times breadth times height. You're going to fill in the actual values. All right, so you're going to write down, what is it? 65 times 26 times 57. Then you're going to press, or you're going to write equals and you're going to type it into the calculator and get your answer. Okay, I don't want just an answer there, please. You need to show the formula. You're going to mark for that formula. Then you need to show the values that you're putting into that formula. That will be your second mark. And only then do you do your answer. Okay, we need to get used to showing our working properly, please. So we're going to say volume is equal to length times breadth times height. That is your first mark. Meaning if it's not there, you might lose that mark, guys, please. Then you say equals. Now you show me which values you are subbing in there, which values you are using. Okay. Yes, you can if you want. Okay, are we fine with that? Then we get the answer, which is, according to the notes, 96330. Is that right? Here we go. But now, what was my original unit here? Unit of measurement was millimeters. But now it's going to be, yes, millimeters cubed. Guys, because you did a millimeter multiplied by another millimeter multiplied by another millimeter, does it make sense that it's millimeters cubed? All right. Are you fine with that one? Okay, number 2. This is obviously a cylinder. So if you don't want to draw it, you can write down cylinder. Now, guys, do you see that it's drawn on its side? It's not drawn on its proper base. What is the base of a cylinder always? The circle. Okay, even if it's drawn like that, it's actually drawn incorrectly. Okay, but you need to use your formula correctly. The radius of the circle is 2 centimeters. Do we all see that? So R is 2 centimeters. And the height of the cylinder, even though now it kind of looks like it's the length, if it was drawn properly, right? So if it was actually standing on the circle, do we agree that 22 centimeters would have been the height of the whole thing? All right, so that is what we're going to use as the height. The height is 22 centimeters. On your own, quickly calculate that volume. Guys, the amount of people that asked me on Monday, how do you find pi on the calculator? How do you type in a fraction on the calculator? I mean, that was an indication that you haven't been practicing, hey? Because I had given you a lot of homework before where you had to use pi. And if by Monday you still didn't know how to find it, I mean, that was telling me you haven't actually practiced. All right, so you need to know where pi is on the calculator. Then you do your radius squared and then you multiply it by the height. Yeah. Yes, round up to 2 decimals, please. Usually if they don't say anything, that is kind of the norm. Okay, so for this one, you're going to say volume is equal to pi radius squared times height. Again, you have to write that down, please. You're going to have to memorize these formulas, right? So you get a mark for actually knowing the formula and writing it down. Then we're going to say pi, the radius here was 2 times the height, which is 22. Yeah.
Instead of saying pi bracket 2 square, can you say 3,14?
You have to use the pi button on the calculator. Okay, 3,14 is going to give you an incorrect answer. Now, guys, one last time. Shift. And you press it once. You don't hold it in. You just press it once. Then you go to the times 10 to the x button there, and you press it. And that is how you get pi. Then you do your 2 squared, which you can write as times 2 squared. That's also fine. It will give you the right answer. Times 22. Now, we don't want this answer, right? We don't want an answer with pi because, I mean, what does that even mean? No one knows. I'm sure some people know, but I mean, that's not really an understandable value. So you press SD there, and it will give you the decimal form. That is what you're going to write down. So you're going to write down 276.46, right? The number after 6 is a 0, meaning that we're going to leave the 6 as it was. If it was a 5 or something bigger than a 5, then we would have rounded up. So we would have changed that 6 to a 7. All right, so that is 276.46. And now this was centimeters, so we're going to write centimeters, but because it's volume, we're going to cube it. Okay, any questions there, guys? That is the last one that we're going to do. What shape is that? It does look like cheese, yes. Triangular prism, right? Do we see that it's actually been drawn correctly? They've drawn it so that it's standing on the triangle, which is nice. But even if it wasn't, guys, just like with the cylinder here, we need to know that if it's a triangular prism, the base is a triangle. Did they give us the perpendicular height of the triangle? Just look at that triangle. Did they tell us what the height of the triangle is?
Yeah.
It's 2, hey? Do we see that? That's quite nice. Did they give us the height of the whole prism? 4.5. Okay, so this is a triangular prism. The base of the triangle, right? Because remember, for the area of a triangle, we need to say half base times perpendicular height. So the base of the triangle is 7 centimeters. The perpendicular height, I'm just going to write here, of triangle is 2 centimeters. And then the height of the whole prism, remember we use a capital H for that, is 4,5 centimeters. Okay, please calculate that volume on your own using the formula that we wrote down. Okay, I don't know if I have enough space here underneath, but I'm going to try. Okay, that's the formula there. Guys, you don't have to put times everywhere. You can actually just write it as one thing as well, all right? Because when we are, remember when we did an x times y, we can just write that as xy. Okay, so it's all right if you don't have all those times symbols there. Just to save some space, I'm going to write it next to it, but you're supposed to write underneath, hey? Yes?
Could you, using the time to,
Yes. Yeah, you can. Just make sure that it doesn't look like a comma. Okay, because that could be confusing. But yes, you can use the dot. That's fine. You can also just use brackets for all of these. All right, so you can see now I put my 7 and my 2 in brackets, but I could have used the times there. I could have put the 4.5 in brackets as well. It doesn't matter. Okay, as long as you're showing that you're multiplying them somehow. Okay, let's see. I'm just typing this in as well. Times 2 times 4.5. And I'm getting, so guys, when you type it in, you actually get a fraction. Okay, we're not going to write the fraction down. Again, that's not very understandable in terms of measurement. So we press SD and that will give it to us in decimal form, 31.5. Did you guys get that as well?
yeah.
Okay, so just going to write it here underneath, 31.5. And what was this? Centimeters. So it's going to be centimeters cubed. Okay. Any questions on volume? Are you fine? All right, guys, that is your homework for tomorrow. An exercise from the Platinum textbook. You can see those numbers. And then you're going to find the volume of these two as well. Maybe do these two first because it is in the notes. And then you do the exercise after that, but it's up to you as long as it's all done. Right, you can start working on that now, guys. You still have 20 minutes. You can finish it in that time. Please note that in number 1 here, they've given you the diameter. Okay, I'm just pointing that out. They've given you the diameter, they're not the radius. So do with that what you will.